Hello, welcome back to another lecture. Here we're going to analyze this arch, and we'd like to know what is the maximum force in the arch at the reaction, and also what's the force in the arch at the crown and halfway through here and at the reaction. And also we'd like to know what kind of a tie rod we need here to pull the arch back together. As we talked about before, the difference between arch and cable is arch is in pure compression, cable was in tension. So all the forces in this arch is in compression. And in this example, what we have here, we have this arch, and it's about 150 feet long. The load that it's going to carry is going to be 2,000 pounds per foot. And so we want to find out first what the reaction is, and also what is the tension compression force here, here, and here at this point. Let's put a name or a number on here. I'm going to call this point A, let's call this B, and this point C, and right here called D. And the arch height is about 75 feet at the center, at the crown, and our goal is to find the reaction and the horizontal thrust over here for the foundation. Let's idealize these arches both pinned on both ends. So I'm going to go ahead and replace these with the equivalent force. There. And I'm going to go ahead use reaction force here. And because this is a reaction force, the weight is pushing down, so my reaction force is pushing back up. The weight is pulling out, so my reaction force is pulling back in here. So I have AX and AY. And same thing on this side. I have BY and B of X. Now that we have all these two, let's figure out, we know what the problem right here is. We have four equations, 4 unknown and 3 equations, so it's indeterminate, so we gotta solve it. Of course, we know this is uniform distributed load. The reaction force basically is going to be WL divided by 2, or we're going to go ahead and calculate our own way. I'm going to say, because this is a symmetric, AY is equal to BY, but let's go ahead and figure it out. And we know AY is going to come out to WL divided by 2. Let's prove that. Right here, that's going to constitute the force of that. And that's going to be 2,000 pounds times 150. Let me write it down. It's 2,000 times 150. And that comes out to, I think it's a 30 kip. 300 kip. That's 300 kip. Yeah, so that comes out to 300 kip. There. So we're going to take a moment about point B. I have already figured out the concentrated. This is the uniform distributed load, and convert to a concentrated load. It becomes basically 2,000 pounds times the length, which is 150, comes out to 300 kips. So let's go ahead and figure that out. So I'm going to start from the left to the right. I'm going to have AY multiplied by 150, and that's going to be a clockwise rotation, so it's a negative. So minus AY times 150. And then the next load I have is vertical load. These cannot take a moment, but at this point they are in the same line. So it's going to be 300 times 75, and that's going to be counterclockwise, so it's positive. So it's plus 300 times 75 equals 0. So if I calculate that, my AY is going to come out to 150 kip. So now if I want to figure out my horizontal reaction, because I got summation F will not do it, this is indeterminate, let's cut the structure right in half at C, and then we're going to go ahead calculate it. So I'm going to go ahead, cut it right at C right here, and I have AY here. I have AX here, which came out, which we don't know, but our AY came out to be, and this is basically right here comes out to 75 feet. And right here also is 75 feet, our height. And this is point C. So when I cut this, I have to replace it with a force. And because this in compression, so my force direction is going to be coming in. Because I'm right at the crown, and the crown is basically my force is in a horizontal angle. This is supposed to have a both vertical and horizontal component, but it's all in horizontal component now. So we call them FC. So FSC, which is equal FSCX, and our FSCY is basically 0. So let's go ahead and calculate this right here. And what we're going to do is take a moment about point C with this when we cut the structure. So we got this force, and that force. Oh, I forgot the load itself. So we have the load right here itself. And that was 2,000 pounds per foot. And so the concentrated version of that is going to be right here in the middle. And the magnitude is going to be 2,000 times 75. So this one is going to be 2,000 times 75, and that should come out to 150 kip. So this is 150 kip right there. Now we can go ahead and take a moment about point C. I'm going to go ahead and say summation moment about point C is equal 0. Counterclockwise is positive. I'm going to start from here. I'm going to rotate clockwise, so it's going to be minus AY, which was AY came out to be 150. So this is 150, the vertical. So I got minus 150 multiplied by that distance is 75. The next force I have is this one right here, and that's going to go clockwise, so it's going to be plus, and that came out to 150. And the distance is 75 divided by 2 from here to here. That distance right there, it's say 75 divided by 2. So basically where the load is at the center. And that's a 37.5. So I'm just going to say 75 divided by 2 so we know what we're talking about. So now I got this about this point here. However, this got to take a moment about this point also because there's a distance between here. It's not in the same plane. Therefore, it's going to be AX going clockwise, counterclockwise, so it's positive. So plus AX times 75 equals 0. And if I calculate that, AX should come out to, I have it, $75. So AX comes out to 75 kip in this direction, as we have noted right there. So AX is come out to 75 kip. All right, so now we found that out, and I'd like to know what is the interior force for this arch right here at the point of reaction. So if we take a look at that point, let's call that point A right here. I have the reaction force of 75 kip. Then I have the AX, no, this is 150. Am I right? Yes. That's 150. This is 75. Okay. So I got 75, and this other force coming in right here. We call that F of A. Remember one thing. this arch is not going anywhere. U-hook is not going anywhere. It's rigid and it's not moving. What do you mean by it's not moving? So when I said it's not going anywhere, it's not moving, it means the summation of all forces is equal 0. If happen to be summation of the forces will not equal 0, that means the structure will move. And when the structure move, what happened? It means it collapse. So we don't want that. So that's why we say all summation is equal 0. And therefore it makes it easier to find out what FAA is. And FAA comes out to I have room here. FAA is equal square root of, I got 150 squared plus 75 squared. Basically, this the resultant force of that will be right here. Write that and equal that. And equal whatever comes out to. Another way we can do summation f of x, summation f of y, but we have to know the angle of this. We don't know the angle anyway. So this way we can find it. And that comes out to 167.5 kip. So right here, my force right here is 170. Yeah, try that again. Let me do this again. So that force over here, it comes out to 167.5 at point A. Now, when we have this arch right here, because the arch kicks out and you want to pull them back in, we can put a tie rod right here. A steel tie rod will hold it back, and that tie rod, we design them for 75 kips. However, if we use the foundation itself and have a big foundation, our vertical reaction is going to be 150 and our thrust is going to be 75. So the foundation should be able to take care of this 167.5 kips, either way. But I want to know what is the force at the crown and what is the force at the point D. Right here at the crown, we already have this. So let's figure this out right here. I'm going to take a summation f of x in here. At this, where we cut the structure, and it's rigid. So I'm going to say summation f of x is equal 0. Going to the right is positive. I have ax, which is 75, and then that's vertical, and that's not vertical. This has a two component, a vertical component and a horizontal component. Because we're at the crown, it's all horizontal. So plus minus f of c of x is equal 0, and therefore f of c of x is equal 75 kip. And if I do summation f of y, see what's the vertical component here? It's come out to 0 because summation f of y is 150 minus 150 is 0, and that becomes 0. So therefore, my compression force at the crown, it comes out to 75 kip. So it's right 75. It's over here 75 kip. By the time I get there, it becomes 167. So if I do my arch right here, the force here is 75 kip. And the force here is 167.5 kip. So what is right here? Let's figure that out. I'm going to come over here, erase this side. So what is at point D? I'm going to go ahead. Point D is right here. So let's erase this here. And there we go. And I got point A. At A, I have 750, and I got 75 right here. So I'm going to replace this with the force coming this way. And that's going to be F of D. Of course, don't forget we have the uniform distributed load on top right here also. And that's a 2,000 pound per foot. Okay, now we have that. We got to find the concentrated version of that load, which is going to be the center of it. It's going to be right here, and that's going to come out to 2,000 pounds. Because this distance right here This distance right here is, we said from here to here was 150, 75, that's 37.5. So this distance is 37.5 feet. And therefore the halfway distance will be 37.5 divided by 2, and whatever that comes out to. So I'm going to just say this distance right here to here is 37.5 divided by 2. And my concentrated load for this is going to be 2,000 pound times 37.5. So that's 2,000 times 37.5. So now those are my first configuration. But remember, something you got to keep in mind is that this force has a two component now. Has a y component and has an x component. And I don't know this height either. This height right here, I have no idea what this height is. Up to here, and that's h d, we don't know. So what we did here, we came in, we cut the arch right at point D, and we'd like to know what the force is here, but I even don't know this distance here, this height. We can figure it out, not a big deal. So I'm going to go ahead and take a moment about point D. Summation moment about point D is equal 0. Counterclockwise is positive. I have 150 times 37.5, that's a minus 150 times 37.5. And then the next thing I have is this one. It's a 75 times, it's going to go ahead plus, so it's going to be 75 times HD. And then the next one I have is this force right here, which is 2,000 times 37.5. So this taking a moment about here, this taking a moment about here. Next one is 2,000. And that's going to rotate counterclockwise, so it's positive, plus 2,000 times 37.5 to make it concentrated. So this is my concentrated load. I was lazy, I didn't just put it over there. And the distance is going to be from here to here is 37.5 divided by 2. Equals 0. And that should give me HD comes out from here. Therefore, my HD comes out to 56.25. Double check my number. I might have made a mistake, 56.25 feet. So if that's correct, if I got that, and then my next thing is going to be, because I have that distance, I have this, I have that, I can just go ahead and do summation fx, summation fy to figure this fd out. Summation fx is equal 0. Going right is positive. I have 75 right there. And nothing, that was a vertical, that was a vertical. So right here, this one is going to be f of dx minus f of dx is equal 0. My f of dx comes out to 75 kip. And that's going this way. Now I'm going to do summation fy. Summation fy is equal 0. Going up is positive. I have $150 right there, 150. Then I have minus 2,000 times 37.5. That comes out to so I have 150. This really comes out to 75 kip. So this load is 75 kip right here. So it's minus, that's a minus 75. Then I have nothing until I get right here. So I got this, and that, and minus FD. Y equals 0, and FDY comes out to 75. Now I have that, then I can go ahead and say, fine. My f of d right there going to come out to, f of d going to come out to square root of 75 square plus 75 square which is 106 kip. So now I say, okay, the force here is 106 kip. Now it's interesting when you have an arch. So now we know the force at the crown of arch is the least, and the force at the base of the arch is the most. Great. I'm going to erase the book and do the next problem. Okay, our second problem is we have this cable here, and it's pinned on both ends, and a cable supporting a 5 kip load at a 25 interval at the center, like this shown. What we like to know is the exact shape of the cable. Like, for example, how long it's sagging here, and what's this angle here, and the forces in each one of these sections. So the first thing we're going to do, because the cable is pinned on both ends, I'm going to go ahead and idolize it and replace them with the force. Reaction force, W. So I have a reaction force. It's going to be going up this way, and because the cable is pushing like that, and the reaction force is going to be the opposite way. It's going to go this way, holding back. So now reaction, you have a force going here, and this cable pulling, and you're going to pull back the other way to hold the cable. And that's going to be AX, AY, AX, and that'd be EX, EY. And the first thing we're going to go ahead and do, we're going to go ahead and calculate the forces. And of course, this is symmetric. We can say, okay, that's a 15 divided by 2. This is 7.5. That's 7.5. And that's one way to say it. Or let's go ahead and do it in a figure out by equation. So I'm going to take a moment about point E. Summation moment about point E is equal to 0. Counterclockwise is positive. I have AY going clockwise, so it's minus AY multiplied by 15. No, do it again. That is 100 feet. I knew that. And then I'm going to have the next one is a 5, which is going to be times 75. It's going the other way, so it's a plus. Plus 5 times 75 plus 5 times 50. And plus 5 times 25 equals 0. These are in the same elevation, so this one and that one are in the same line, and I cannot take a moment about here. So the only unknown I have here, and therefore my AY comes out to 7.5 kip. And we know this is symmetric. AY and EY are equal, so I'm going to say summation f of x is equal to 0. Going right is positive. I have my reaction was 7.5, and because this came out to 7.5, so minus 5, minus 5, minus 5 plus EY equals 0, and EY comes out to 7.5 kip. Now, to find the x is a little bit different. We have to cut the cable because, again, we have 4 unknown and 3 equations. In order for us to calculate AX, we know we got 4 unknown and 3 equations. We already calculated AY and EY. To figure out AX, we have to cut the cable at C. So I came over here, cut the cable at C just to the left of the load, so I don't have to show the load here. And again, when you cut the cable, you have to replace them with the force, which is FC. And this whole thing, it's in a rigid. It's not going anywhere because we replaced it with the equivalent force. Now I can go ahead and figure AX out by taking a moment about this point. And we know this point is about 10 feet lower than that. So we're going to go ahead and say take a moment about point C. And that is 7.5 times 50, and that's going to be minus 7.5 times 50, And the next one is AX, which is going to rotate also counterclockwise, so it's positive. So plus AX time 10 feet. And the next force is here, which is going to be clockwise, counterclockwise, so it's positive, plus 5 times 25 equals 0. And my AX comes out to 25. I believe I have already figured it out. Correct. So AX comes out to 25 kip. Now remember, we have that, and this force here has two components, has the FSCOY and FSCX. And let's calculate the these two components, and we can calculate what FSC is while we're here. I'm gonna go ahead and let's find a color that I like. So I'm gonna go ahead and do a summation of Fx is equal 0. I have minus 25. Then I have nothing, 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 and plus FSCX is equal to 0. Then FSCX comes out to 25 kip. And if I do summation FOY is equal to 0, up is positive, I got 7.5, and minus 5, and minus FCY equals 0, so they become 2.5. FSCY comes out 2.5, 2.5 kilo kips. Now I can find out FSC basically is the resultant of these two, and FSC comes out to square root of 7, no, that's 25. 25 square plus 2.5 square, and that comes out to 26 kip. I get 26 kip here. Check my number. So this has come out to 26. All right. If I want to find out this angle right here, theta, is basically a tangent. I know it's like making a line right here, that be FSC, and then I have the x component right here, and I have the y component right here. The y component was 2.5, the x component was 25, and this angle theta, we know tangent of theta is equal opposite divided by adjacent, 25, so tangent inverse, so therefore theta comes out to tangent inverse of that, and that comes out to I know I did it, 5.7. Double check my number again, 5.7 degree. So now we have that. We can do the same thing for here. It's the same method.